Okay, chapter 5, day 4. What we're going to focus on today is, given a quadratic equation, how can we tell what type of roots we get? So if we don't do the whole quadratic formula, or factoring, or any of that, can we still tell what kind of roots do we get? Do we get rational, irrational? Are they imaginary? So one of the questions they'll ask on the state exam is, what kind of roots do you get? And you have to be able to answer it using what we're going to learn today. All right, so let's take a look at what type of roots we get. Okay, so I drew a parabola across the x and y axis. Again, here's your x-axis, here's your y-axis. And where it hits the axis are the roots. We've already talked about that. Down the dead center of the axis is called the axis of symmetry. Down the dead center of that parabola is the axis of symmetry. And I know you guys talked about that in Algebra 1. And so I want to look at my quadratic formula, okay? So here's the quadratic formula that we learned last class. All right? The quadratic formula is set up such that the first part is the axis of symmetry plus or minus this other part. And this other part is the distance from the axis of symmetry to the roots. So if I took a look at this distance right here, and I took a look at this distance right here, even though it doesn't look it because I didn't draw it to scale, it is identical. And the quadratic formula is set up such that I have the axis of symmetry plus and minus that other stuff. So the square root of b squared minus 4ac over 2a is what this is. The square root of b squared minus 4ac over 2a is what this is. And so the axis of symmetry will always be a fraction. It'll always be rational. And then it's what we add or subtract to that that determines whether our answer is going to turn out to be rational still or irrational or possibly imaginary. So if I look at this fraction, the bottom part is 2a. That will always be rational. It's this top part, the square root of. Sometimes I take the square root of this number and it works out really nice and it's a perfect square, and sometimes it's not, like 7. And the square root of 7 is what we call an irrational number. So really it's this part only that determines whether our whole value is rational or irrational, or maybe it's imaginary. So we're going to hone in and focus just on this part of the quadratic formula. So that part of the quadratic formula, the b squared minus 4ac part, is called the discriminant. And that's an important vocabulary word. So if I say, what is the discriminant, you'll calculate b squared minus 4ac. It is called the discriminant because it determines the type of root that you get. So I'm going to make a little chart. If b squared minus 4ac, if that part is positive and a perfect square like 16, I can take the square root of 16, I will get real rational because it's a perfect square. All right? So perfect square leads me to rational. It's the most important connection there you need to make. Perfect square and rational. And they will be unequal because these two numbers are not located at the same spot on the x-axis. If this b squared minus 4ac is not a perfect square, so not a perfect square, that will be irrational. Those two need to be linked together. Not a perfect square like 7. The square root of 7 is not a nice number. It's irrational. It just goes on forever. All right? And they will also be unequal because it will not hit in the same location. So it has to be unequal. So the difference between these two is purely a perfect square rational, not a perfect square irrational. Okay? If the b squared minus 4ac turns out to be 0, not only is it rational, because 0 is a perfect square, it's equal. And so I want you to link the value of 0 to the word equal. And what happens is if this has a value of 0, then come up here, this distance then is 0, because 0 divided by anything is 0, and the parabola sits right on the axis of symmetry. So take a look at the graph. The parabola sits right there, touches at the axis of symmetry in only one place. So even though if I factored this, I'd get two answers, both of the answers are equal. And so I'm going to get two numbers that are equal to each other, and I get what we call equal roots. And the graph is tangent to the x-axis. Tangent to the x-axis. So sometimes they'll ask about what does the graph look like. So when it's equal, it's tangent to the x-axis. And the last situation is, I do b squared minus 4ac and I get a negative number. Now up until today, you'd say, well, I did something wrong. You probably didn't do anything wrong, but negative numbers under the radical lead to something that we're going to find out about next week called imaginary roots. And so for right now, all you need to know is if this is negative, we get imaginary roots. Those two have to link together. The graph looks like this. The graph will not hit, whether it's right side up or upside down, the graph does not hit the x-axis if the roots are imaginary. Okay? So a question you might get is, what kind of roots do we get? All right, so we have a problem, y equals 3x squared minus 2x plus 1. Well, you have to identify a, b, c, just like before, b squared and b squared minus 4ac. It is this part here that's the most important, because this turns out to be negative 8. So b squared minus 4ac is negative 8. Negative 8 says that we have what type of roots? Let's go back to our chart. Negative. Hey, there it is. Negative, we get imaginary roots. And so our answer is just imaginary, okay? If I were to graph this, the graph would not hit the x-axis. And so the question, what type of roots? I got imaginary roots. And that's it. We're going to practice that in class.